All right, we're live. Whew! I'm a little bit behind this morning. Usually I'm like within 30 seconds, but today it's a little bit worse. So, what's going on, man? Good to see you.
Yeah, good to see you too, Nick. It was a long time
Yeah.
since I can see you.
We got a bunch of stuff going on in Helium Land. I think Dave is telling me March 27th we're switching to Solana, so that should be good.
Wow,
Yeah.
wow, very
I,
short.
I
No.
don't see how anything could possibly go wrong.
Yeah,
Yeah. I'm going to put you up here at the top and then say hi to all the
yeah.
peeps coming in. Oh, man. We had Jamie on last time. We're supposed to have Germ coming on this time. I'll see if he's going to ping me or not. There you go. Speak of the devil. Let's bring him in. What's up, Germ?
Hey everyone.
How are you doing? Of course, my camera
Great.
decides that right now is a great time to lose its shit. Ugh, what a morning! What a morning! Let's see if we can get that thing to switch over. Maybe not. Minor disaster here. Well, for right now, maybe I just won't do camera stuff. Sorry, guys. Usually I have my shit a little bit more together. Lee, what's going on? Gregory, Siegfried, Garum, Kenny, all the peeps. It's a pretty ripping day today. It's actually nice outside. It's 54. San Diego, that's not too bad. So, yeah, what's going on in the world of helium? If anything.
Paul? Yeah.
There we go.
Yeah.
Oh, serious technical
I wanna talk about
difficulties here in
take a
the
second.
Crystal King HQ. Paul, what's going on with you, dude? What's new? You got this LNS thing that you've been standing up for a while. What's the latest on that?
Yeah, what's up on my side? A lot of work on the chip stack.
Okay.
Chip stack development, integration of Helium and chip stack. So made a lot of work on this area. So not taking a lot of time to communicate on new stuff, as this is what I'm working on.
Mm-hmm.
Some crash of my ETL that takes me some time also, but basically nothing. Yeah,
Okay.
nothing really special.
Nothing super special. I mean, I'm hearing all of these folks as I talk to them, kind of wondering what's going to happen with when console goes away, which I don't think will be for another couple months at the very fastest. And I'm steering as many of them to you as I can. But there's a couple other folks also coming up. They're going to run their own. I guess, is it instance of console? Is that the right way to say it, or is there a better way to do it?
Yeah, I think we can talk about instance of console as a. I mean, um, what instance of console could have the idea that it's not a separated thing, but it's really a separated thing. So when you have your console, you are like in a private network, okay, but
Yep.
getting benefit of the hotspot. So yeah, it's your console, yeah, not an instance of a global thing. But yeah, it means basically that you can have your own console. I mean, as you can already have it for sure. It means that
Yeah.
with the new LNS, it won't change basically the way the network works. It's just a different software that allows to get more capabilities coming from LoRaWAN. So which is really interesting. And basically what people have in mind is it's not a switch on switch off. I mean, it's not a big bang things. During a certain period of time, the device will continue to communicate on the previous console, and you will have the ability to migrate to the new console, so the chip stack environment. So basically the migration will be something like 6 months duration, and people will have all that time to do the migration. If they have 100 of device, they can migrate one devices, verify that everything is okay, making the integration working and all that stuff. And once everything is working correctly as they are expecting, they would be able to migrate the rest of their fleet. So it's really a smooth migration. Really important.
Cool. I'm excited to see kind of what happens. I keep saying like, oh, I gotta go sign up for Paul's thing, and then I get zinged off in a million different directions. So yeah, I
I'm
want to
going
see
to
inside.
join with the right browser. I
Okay.
clicked on here, and I need to share my screen, so you're going to
Okay.
see this briefly.
Yeah, yeah. We'll see you right back. It's one of those days. That's how it goes. All right, there we go.
Well,
He's
maybe I
coming
can.
back.
Yeah, you're back.
Yeah, Paul's like, oh, you're just disgusted at the lack of technical expertise on this call.
There's more technical expertise on this call than most, I think, in the world. So what are you talking about?
Yeah. Yeah,
Well,
well, just not in the
um,
videography side. What's new with you, Jerm?
my news here is what I'm sharing is the IoT proof of coverage roadmap.
Okay.
There's a lot of things going on with Helium, and you've seen recently the mobile group
Yep.
the mobile sub-DAO is starting up, asking for volunteers to help write HIPs for proof of coverage there. Well,
Yep.
we're doing the same thing for IoT,
Okay.
and this is just published last night. The link doesn't appear to be live, so that's why I had started up on my own server. But you're seeing what's going to be live as soon as we get fixed. And it's all about what's next for IoT's proof of coverage. Proof of coverage, of course, is the thing that makes Helium unique in the world of blockchains. And it's the work unit
Yep.
that you get rewarded for, and it makes the network really super cool. So I want to talk about the things that have that changed since proof of coverage first started. And these are things that are really important. The network has just grown phenomenally. If you look at what's happened since the first hotspots came online, maybe a batch of about 600 to today, we have maybe 600,000 actively working. And there's been new radio hardware has been released in the last 4 years, almost coming up since the network started. There are new features to LoRaWAN we need to worry about and incorporate. Gaming has become a problem. People have gotten more sophisticated in the ways that they try to cheat the network. And we've rescaled the network with HIP-70. It's a huge one. And as a result of that, there's lots of different actors on the blockchain, different actors in the network. We've got the validators, we've got oracles now, and that's a big part of it. And finally, big one here is that we just got a huge community of talented people from all over the world. And they all contribute in different ways. And all of these things have happened in those last 4 years. And PoC hasn't really done much with any of these, and that is until now. So the first steps, step one that's already happening, is that we are moving to Oracle-based proof of coverage. And this is super key for a couple reasons. Number one, it gets rid of some limits that we've had on PoC for a long time, limits that have slowly ramped down as the number of hotspots grows. We've had to ramp down things about PoC that just make people frustrated, that make me frustrated. And what are those limits? One of them is a hotspot can only really expect to beacon 2 times a day. Once every 2 days. It's even worse. And when a hotspot beacons, we only can record about 14, maximum 14 hotspots that have witnessed it. And that's kind of frustrating for a couple of reasons. Most of which is that it's really hard to see when you change something. It's really hard to see how much effect it has on your rewards. Have you done a good job? Have you plugged in that antenna correctly? Have you moved it to a good place? It's going to take you several days to find out. And if you're putting this in a place that it's hard to get to, that's really frustrating. You have to go back and forth and back and forth. We used to have something called discovery mode. Well, that's not alive anymore, but it is coming back practically due to the way we're going to change things about PoC. So
Really?
with HIP-70, the move to oracles, we are going to do some radical things. We're going to take the wheels off, or take the stops off, keep the wheels on. And one of those is we're going to increase the beacon rate. And you've already started to see that going from once every 2 days to now it's up to about, we want it to be 4, it's at 3, because we're still using the L1 blockchain at the moment, around blockchain. But I'm hoping when we get that taken away, when we get fully over to Solana, we can really work on this one. And increasing that beacon rate means that you should now see beacons about 3 times a day right now. That's what you should be seeing. If not, there's something going on with the hotspot. Definitely need to work on that. But the next really key thing of this is that we do not need to have the witness rewards tied to the witness list, meaning we'll have the ability from that oracle, that PoC oracle that's running, to publish the full witness list. for every beacon on a S3 bucket. And we'll share how that you can access that and see that. We'll expect.
Hang on a second. What's the
community tools.
implication
Yeah.
to that? I don't understand why
What's the
that's
implication
important.
of that?
Yeah.
When you beacon on a hotspot, especially in a hotspot that's really well situated, it often is heard by hundreds of other hotspots.
Okay.
And if you've ever gotten to use discovery mode before it got shut down, it was really cool. You could hit discovery mode, get your hotspot to beacon, and you could see live the hundreds of possible hotspots that actually heard your signal. And it gives you a really good estimate. You can start to see, oh, wow, I'm broadcasting better to the west than the east, and things like that. We haven't been able to show you that. That happens all the time when a beacon happens. We can only record 14 and show those to you in Explorer because we have to store them on the blockchain. So that's an unnecessary restriction. It doesn't have to be there because we don't need to report all of this on the blockchain now.
Right.
We can report it on in a space that looks similar to the blockchain in an API or a S3 bucket, as I'm calling it right now, where you can download the data yourself, other people can download it, and display it. So you can see for every beacon your hotspot's ever made under Oracle-based PoC, you'll be able to see all the
Paul's got a question. Paul's got a question. Hold on.
Go for it, Paul.
Yeah, my question is the following. I mean, currently all the information are stored in ETL, and so we have a bunch of services, a large ecosystem of like 𝗪𝗶𝗀𝗀, and many others that are giving an analysis of this data to the hotspot owner. And it's really cool to have all this data and more data accessible through S3 buckets. But what I'm not clear with it is how it's gonna kill the existing ecosystem of application, and if we're gonna have compatible API, or if ETL is going to keep receiving this information. How this transition is going to evolve?
Yeah, so let's talk about like the ETL, if everyone's familiar with it. If not, we should definitely spell it out. That stands for extract, transform, load. It's something that's key for any, it's key for blockchains, especially because blockchains store all the data in a really weird, hard to read format. You have to download the blocks raw and piece them apart. So an ETL is an important part of that takes the data from the blockchain, breaks it up, and puts it into easier to chew pieces, and it digests them for you, and it displays them in different ways, puts them into these SQL tables. If you've ever worked with the wonderful thing that is structured query language, that is still quite geeky, I admit. But from there, we can take all that data and then do things like make Helium Explorer, which shows you all of the hotspots in the world, right? I won't show you what Explorer does. Everybody knows what Explorer does. So the ETL is the way that we do that. It follows the blockchain, and it takes all these things out and puts them in these tables for other developers to then easily display the data. It's a beast to run. If you've ever run one, Paul, I'm certain you've run one. It takes terabytes of storage. You have to have a very beefy machine. It sometimes gets stuck because it's doing so much data processing. And it's going to be hard to have an ETL under Solana. The ETL itself is probably going away. It's going to have to be replaced by other community tools. I don't have the story myself all set, but we're going to be exporting a lot more data and having the community find ways to use these tools. I think at the foundation, we're certainly going to have some opinions about how those tools should arise, what they should look, and maybe host some of them ourselves. But we do recognize, because we got this giant community now, we can possibly give grants for other people to develop these displays. The data will be there. It's important to say that it's going to be there. It may be hard to see it at first. But I'm pretty certain there's not going to be the exact ETL that we have now on the Helium L1. It's just, we're going to stop the Helium L1 chain. We're going to move over to Solana. And a lot of the data that the ETL displays now is going to be in something similar, but I don't have the exact answer to how that's going to look yet. That's a big question. We're aiming for March 27th to have that Solana migration complete, right? So there's companies like Hotspotty and Paul, your company, and the stuff that you do. This opens a huge ecosystem for people to come up and show up and have different ideas and display them. But the ETL, as we know now, is going away.
Yeah.
Okay.
So not an easy answer, but I'm excited about the amount of data we can get. We just have to get it all out together.
Yeah. All right. Let's go back to the other page. I think I've got our setups down now, so I can actually switch between them. Jesus.
Awesome. So the next big step after we get that is economic scale adjustment. So if you've ever set up a hotspot, you're aware of something called the transmit scale. It effectively tells other people how much they can expect by witnessing you. It seems a little weird when you think about it that way, but it's constructed that way for a reason. And this all comes from HIP-17, which changed the way that we reward hotspots on the network based on how many hotspots are in any given area. That's called the hex density target. And it's a list right now of about 7 different area blocks. They're different hexagons of different sizes. And for each size, we state how many hotspots we think should be in a region that big to make effective coverage. And if we get more hotspots than necessary in that region, everyone in that region gets derated. Their transmit scale gets brought down. And so the idea here is to discourage people from putting hotspots in places where we don't need them, putting too many hotspots in there. And since HIP-17 was adopted in late 2020, we have not touched the initial targets in there. They're very arbitrary. I think at hex 4, the number says there has to be 820, ideally 820 hotspots in a hex 4, which is, 683 square miles. I nicely put the kilometers in here first, or 1,700 square kilometers. That's a pretty big area. By 820, who knows? It's definitely time to revisit that. It may be time to pop some of these scales and make them go away. Res 4, that big one, may be the first one on the list. So this is something we need to look at and revisit. I think 𝗵𝗶 thinks this too. 𝗵𝗶, CEO of Foundation, thinks that these limits are just a little bit arbitrary, and we need to look through them again. Make certain that they're making people get rewarded for having good coverage in areas that need to be served. But we really need to get the word out and get people to put hotspots in areas that there is no coverage, and really make that rewarding and to get the network to grow.
Interesting. So there's like a massive revisit of 15, 17.
Exactly. 15 is the thing that says makes hotspots beacon on their own, essentially. But 17 is the one that does all that hex scaling. So
all right, Paul, what do you got?
Yeah.
One point on this. I mean, currently the network is really a city-based network, and I mean that's really great. There is a lot of use cases in city, but it also need to grow in a zone with less density of people, and I mean basically the PoC rewarding as it is made today is really made for a large concentration in big cities. And I mean, do you think that we can change this to really motivate people to and start to deploy new hotspots in more rural zone or area around cities to expand the network coverage?
That's the goal, right? That's what we know we need to do to really make the coverage amazing and usable by anybody who wants to use this incredibly scaled, incredibly covering network all over the world. We need to get people deploying out in these, I'm going to call them rural regions, or regions that don't have coverage, right? And having more hotspots in cities, it can open up other things, but it's not what we really need right now. And that's entirely what this goal is about. I mean, let's talk about maybe having high density is helpful in some places because we can start to, one of my future visions in here is actually get us off the single 8 channels that we use right now and get us into, in places in the world where we have a lot more channels, like the US, we have 64 at least available LoRaWAN channels. We're only using 8 of them on Helium. In cities where we have really high density, maybe we can start to get hotspots to listen on different channel groups, and so that we can massively scale up the data throughput in the cities. So we're not necessarily need to get away from high density, but we need to reward people in those low density areas, and that's exactly what this is about.
Cool. I got 2 questions coming in on the chat. I'll drop them actually in on the screen. So this idea of lone wolves, is the new PoC going to address that? Because it's, I think one of the things that Hackett said is that without proof, there's no proof of coverage. So if you're only by yourself.
Lone wolves are really hard because they it's hard for them to prove they have coverage. There's a thing deep down in here, which I'm going to get into, which will be exciting. It's bringing about mappers. For a long time we've had mappers in the network, but bringing them in and making them actually reportable entities, to give you a very geeky phrase, is super important because that'll help lone wolves, people who have deployments that are great because they're out in the wild, but they're not doing so great because they can't prove that they're actually there. And it's really important that we prove the coverage, not just fake it. No, I'll get to that. That's great.
All right. Last, are you going to get to this one too? This idea of where we don't have hotspots, we're going to put bounties out there, or is that not going to happen?
I think this has some merit. I think if you look at the way that the 5G mobile network is being structured and the proof of coverage there, there is this concept of only rewarding the first few radios in a hex, not necessarily the first few radios in a hex, the best performing radios in a hex, and anyone else who's not performing is not useful coverage and doesn't get rewarded. That's an element of the mobile, and I think we can kind of bring that in here. I personally am worried about like being the first there doesn't mean you're going to be the best. It doesn't mean you're going to stay there. The network needs to make certain that if you're the first, that you're still there. We don't want to have someone plant a hotspot, get that first to plant flag, and then die, and then no one can serve that hex. That of course would be horrible. But I think if we change it to best or something like that, and you get to hold that spot, and it discourages anybody from deploying more in an area that doesn't need it, we can certainly do that. The thing I should have brought up here is that we have open calls right now for community members to participate in really high-level technical chat and direct the next series of HIPs. This is going to be the talking points, I think, about that. But on Discord, if you've seen that announcement, it's really important. Anybody who's watching this should join that group, and we can talk about these things. But the lone wolf problem isn't easy to solve. We just talked about that one, right? And the bounty thing, I think, is open for discussion. It's something that we should put in the roadmap and talk about.
All right. Sorry, I'm bringing us back to screen. I'm skipping around here. Sorry, buddy.
Yeah.
Okay, so these are the
we
next
talked
steps,
about. So there's, after we get these big 3 things done, which I think are in the immediate horizon, there's a whole bunch of things we should do, and it's not clear what order we should do them in, or whether we can do them all together at once. I think we can do a lot of these together, meaning deploy them at the same time. But it's pretty clear that one of the next things we need to do is really play with different algorithms and vary the way that proof of coverage beacons work. It gets a bit geeky here, but some of these are pretty easy to understand. What if we randomize the transmit powers that a beacon is sent at? Randomizing transmit power can make it easy to tell if someone is cheating or lying about receiving the beacon, because over time, their reception level should go up and down with the beacon being transmitted up and down. And if we don't see that, we have an idea that someone is not actually next to the beacon that they think they are, or that they're telling us. On the same scheme, we can randomize the coding rates. These are the spreading factors. I won't go too deep into those. There's some cool ideas that Nova has in their back pocket that I think we should work on. And this is adding or removing error correcting codes. This helps you detect whether you're actually receiving it over the air or not, because there's certain things that, certain errors that normally creep into radio packets that are hard to model, but we know about. And if we remove these error correcting codes, we can see these errors and say, oh yeah, you're experiencing the errors the same way we expect the radio network to do. So maybe you really are there. And another thing we can probably do is bring back the multi-hop beacons. That was kind of a bummer in the old days, but it's kind of cool in that it allows you to target a specific listener from hop to hop.
Yep.
And I think that can kind of help defeat some of the packet stuffing networks that we're seeing. I won't go too deep into what packet stuffing is unless you guys want a description of that.
No, I think
so. That's the next step in there.
One thing to go back to, let me change the screen and bring this comment up because I think it's reasonably interesting, is the way that the network was designed was to incentivize putting hotspots out there, but ultimately the goal of the network is to provide coverage. Yeah, what do you think of this? Because I can see Jason Greyhat-Guy's point is like, who cares about if it's overcrowded?
Well, I should say there should be no penalties, but how about I tell you there should also be no rewards? Is that the same thing, or is it just putting it in a nicer word?
It's interesting. I don't know. Paul, what do you think? I mean, you're coming in from more the lower one side.
I mean, I don't feel benefit for a customer to have overcrowded eggs. I mean, when you have already 2 or 3 new eggs, it's already good enough.
Yeah.
I mean, we can imagine that if the network size is decreasing for any bad region, having an overcrowded eggs can be a kind of security, but if it over 5 or 6, it's really, really large. The problem of overcrowded eggs is that it's pushing people to not looking for other places which are more interesting in terms of network coverage. And basically, the PoC algorithm is to create the network coverage. So it's to push the actors to find a good way to extend this network. And this overcrowded eggs rules is a way it pushes us to find not just asking our neighbor if they want to add a hotspot, but go to a friend of friend and families and so on, or to find new places. And I think it has been super efficient, and it's still really efficient. And the other advantages also is, I mean, you are deploying your hotspot at your home, for example, and you're the first here, and your neighborhood is seeing that it's interesting, so they are created hotspot at this place, and at the end you have no revenue. At the end your traffic is going really low. So I mean, it means that it's better for you to not talk about it, to make sure that you won't have a lot of people in the same eggs, and it's totally not efficient for making the network growing. So in my point of view, this is a really, really interesting rules.
Yeah.
It's really interesting to have a super dense network. As a one question I had for you, reading your what you tell about new algorithm is one thing which is really interesting is we could do really a scene tracking without GPS using the RSSI, and thanks to this dense network where we in a single edge which is 300 meter long, you can have up to 5 or 6 hotspots. I mean, we could get a precision from a couple of, I mean, tens of meters, like 100-meter precision or something, which is really interesting. Okay, it's really something really powerful for many tracking application with low cost tracking application. And well, I mean, the problem we have with Helium is that some hotspots they are indoor, some hotspots they are outdoor, some hotspots have a certain gain of antenna and so on. And if you want to be precise in your location, you need to have good algorithm to understand the RSSI. And what is the good advantages with PoC is that you can measure the RSSI loss, the signal loss between hotspots. And so I'm quite sure that with a good algorithm, we could really have great information about what are the indoor, outdoor hotspots, what is the RSSI at the different distance for every of the hotspots, and be really efficient in terms of triangulation and localization. I'm quite sure that it could be really interesting, and it could also be, I mean, an added value services. Like it's something which is sold by different network operator, and it could be a way to get some rewarding or DC consumption or things like this, which could be also interesting. I don't know if you
Yeah.
have this in mind.
Well, I am. And let's get back to the difference between crowded and overcrowded. The things that you just talked about, Paul, are absolutely important to have multiple hotspots in a hex. We need that for many of the reasons, one of which is simply redundancy. If we want there to be, we need more than one hotspot in hex, because if a hotspot goes down, we need the other hotspots to be able to pick up the data that's transferred in there, so that a network user doesn't have to worry about an outage. Really, for them, it should just appear to be online all the time. So we need multiple hotspots in every region for that alone. But two, these exciting ideas that you've brought up, the ability to do triangulation or trilateration based purely on the signal strength. I think it's something that TrackPack, actually, I would be so cool to have Neil on here to describe some of the stuff that they've done. And this brings the cost of sensors down. You don't have to have a GPS in the sensor. Brings the cost of the hotspots down, or keeps them down because they don't have to have GPS in there. But it brings this amazing trilateration effect into play, where we can pinpoint sensors purely by how strongly they're received. And for that to work, you need multiple hotspots, multiple gateways to pick up the signal. The more, kind of the merrier, because it helps get rid of the noise that's inherent in radio strengths. There's all sorts of things that can mess with how strongly a hotspot receives the signal. And they're just really hard to predict. But the more hotspots you have in an area receiving it, the more that those things kind of even out. So it is important that we have redundant coverage, but we don't want to have too much. There's a point where you just have too many hotspots in hex, and it's not helping anything. In fact, it starts to pollute the airwaves with their beacons and all that. So don't confuse overcrowding with density. There's some density necessary. That's absolutely true. So I hope that answers that question.
Yeah. I'll let Paul answer that in a second. Let's pause here and kind of just realize how complex and ambitious this is. This isn't like a small change that we're making, and there are details throughout this entire change that are going to have to be ironed out. And I think if you look at it rationally, there's details that we as a community are going to get wrong. And so I think one of the expectations to set when you embark on an ambitious project like this or a change like this is expect that some things are going to get gotten wrong. Some people are going to be under rewarded. Some people are going to be over rewarded. Some parts of it aren't going to work. Some parts of it are. One example is that the trilateration idea, which is that you got a bunch of different hotspots and you can get the signal strength from each hotspot so you can pinpoint where you are. That only works if the hotspots are asserted correctly where they're supposed to be. If they're off by some amount, and depending on how accurate you want to be, that amount can change, then that may not work as well, right? And a lot of early hotspots at WAN, in order to maintain their privacy, and I thought this is totally legit, did not assert exactly where they are. So it's pretty interesting to me, and also just something to keep in mind as we go forward with these big changes, that not everything is going to work perfectly right out of the gate. And hopefully we see some cross-pollination with other projects like GeoNet, where they come in and they provide centimeter accuracy for a hotspot, and all of a sudden now the trilateration is actually super useful.
And that is super key to recognize that we don't necessarily know what's best and what's going to work. We need the flexibility to play with it and try different experiments. And that's why these are called experiments here, and that's why I've highlighted it. It's really hard to predict which of these is going to win, if any of them, or if they're all good ideas. But in order to get to the spot where we can do that, we do need beaconing and the stable reporting that we're getting from Oracle-based PoC. And that's why that's first, and that's why this is next.
Yep.
So absolutely, yeah, we need to try things, and we need to get ready to get rid of something if it's not working.
And it's super cool to get really more data coming from the new PoC and the new capability of chain PoC. I mean, it means that we can have more beacon, we can have all the witnesses for every beacon, and this is a really interesting database to verify the location of hotspot, to do this triangulation and so on. And it's quite interesting. And what is the benefit for everyone to have this kind of triangulation solution, for example, is, I mean, if we want to enable this kind of service, it means that we're going to consume more DCs. Instead of having only a single hotspot getting one DC for reporting a data, if you want to do triangulation and if you want to be really precise, you will accept something like 10 or 15 different hotspots reporting information. It means basically you can spend 10 or 15 DCs on every communication. And that's really interesting, because the value of the network, the reward of the hotspot in the future will be based on the data communication, not on the PoC itself. So this is what we have to promote by providing good service.
Yeah, it would be great to have Michael Verling on, having talk about the side, the data part of this. This is, of course, just PoC, and PoC does have a function, but we should all admit PoC eventually needs to go away, and this needs to be a network that is entirely rewarded for its data transfer. The PoC is here to help us grow, help us keep things in line. PoC is kind of the future customer paying for data credits. That's the way I like to think of it. We're kind of borrowing from the future to make this happen. So,
I think we can also have a different point of view. But basically, I mean, a Helium is a really low cost IoT network. I mean, if you are a device maker and you are using Helium, you are paying 1/10 of the normal price you pay with a telecom operator. So that's really super cool for a lot of IoT business, and it really makes it possible, viable, providing a low network cost. But in the other end, it's a really valuable network. I mean, it's the largest LoRaWAN network in the world. And there's no reason that you have to be low cost, because it's super redundant, it's a global coverage, you can go private. There is many good things that means that the network is really valuable. And so in terms of service level, it's really good to stay with a low level price, low cost network, because it enables a lot of IoT use cases. But it can go to a higher price, like consuming many DCs to get added value services. And that way, I mean, you would pay not more than a classical telecom IoT network. You will pay basically the same price than a public network, but you will get much more services you cannot get on this kind of network, thanks to the redundancy, thanks to the high density and that stuff. I think we need to consider this also as part of the equation, as it's really what will make this network a source of revenue for everyone and valuable network for everyone.
What hot items are in the chat? I should have checked in to see the chat myself too.
Oh my God, there's all kinds of stuff going on. I think there's just so I'd say it's kind of a combination of uncertainty and misunderstanding, and then just different opinions. I think this is so. I'll blast through a couple of them quickly. So there's some stuff. Kind of Chad. Whoop! I almost banned him. Questions about running an Oracle, right? How much staking that is, how much the Oracles make. There are questions about. I think there's this really good point from Hack, where we're all part of this big wireless experiment. This is not like subscribers of a perfect service like Amazon or Apple yet. And so I think I'm seeing that, this works pretty well for me, but maybe for a commercial entity, it's not quite there yet. Although I bet Nova in 1663 would disagree. And then what else? And then just kind of discussion about whether or not GPS or hotspots or trilateration or whatever is better. So
yeah, a lot of great comments. And to the part about like being afraid of experimentation, I don't think if we do the things that I'm calling experiments, they don't need to be visible to the users of the network. These are things that can be run side by side. Different hotspots can be running different types of PoC. We can gather data. People can volunteer into beta programs and stuff like that. Yep. PoC it never should. And if it does start to affect data transfer, we need to fix it. It lies right alongside it, and it should be totally unaffecting anybody. So we shouldn't have to worry about these experiments interfering with it, just being still a world-class network. In fact, it makes it stronger that way. But I like those. I like the sense that. If you want to be on the experiment, be on the experiment. If you don't have to. I think that's how it's going to be structured. We'll find ways to do this and do this testing, as we have done before. What was that other one that was really the last one? It wasn't hacks. It was
this one.
80 hotspots. Yeah. 80 hotspots. Maybe there's a point where you get too many.
Yeah. So there's going to be some discussion about this. Yeah. Paul and Jason at are going getting after it.
Okay. Yeah, the type of argument I'd love to get in here.
Yeah. All right. Let's keep going though, Jeremy. I know we got a lot to kind of get into.
Well, there's not a whole lot more here. I mean,
okay, good.
So much more I wish I had. So one of the next steps we should be doing somewhere in here is modeling coverage. Proof of coverage shouldn't be wasting its time proving coverage that's impossible. Like we know that LoRaWAN signals do not go through mountains. And there's no point rewarding coverage that can't be done. And we can actually tell. We have hardware tools and software tools, more likely software tools now, and open source databases, some of which were produced by the U.S. government, like the shuttle missions in the late 90s that mapped, about 80% of the world's surface down to square meter kind of resolution in terms of profile.
What do you know about the shuttle missions, Jeremy?
Don't get me going. Anyways, that data is really cool because we can use it inside of the IoT verifier oracle to help prove if a hotspot says it's in a certain location and has a certain height recorded, we can actually ray trace out its beacons. We can find out where in the world those beacons could possibly be received. And we can also very quickly tell where they cannot be received. There's, radio is voodoo. A lot of people like to call it voodoo. I don't think it's quite that strange. There's a lot of components to it. So no simulation is perfect. We need to give this a lot of latitude. And, LoRaWAN does some amazing things. For example, here in the San Francisco Bay Area where I am, signals routinely somehow skip across the water of the bay. That's a known phenomena. We should incorporate it in here. I don't want to scare people who think that, I've got some really cool tropospheric ducting things that happens in my hotspot. Those will be allowed to continue. But there's certain cases where we know there's no way, if you're on the other side of Mount Everest, that you're going to get a signal from a hotspot at one of the base camps. It's just signals don't travel through mountains. So one of the things we could do is have the verifier do this for every beacon. And for those regions where those hexes where the signal can't be received, yet it is mysteriously being received, that's a good way to detect gaming. You should check something called packet stuffing. And it's a good way to sort of build up a trust network of who's a good hotspot, who's who appears to be actually reporting the real world as they see it and who isn't. And model coverage will give us a lot of it. We'll start to build up this trust network as I'm speaking and be able to bolster proof of coverage. We'll be able to trust certain hotspots and their coverage a bit more, and they can be used to help verify other hotspots who haven't been in on the scheme yet.
All right, Paul, what do you got?
So that's what model coverage is about. Yeah.
I saw Paul raise his hand.
Oh, he's muted.
Oh, you're mute.
I bet he's got a lot to say.
Oh, yeah, sorry. I mean, practically speaking, I have a lot of example of hotspots that are communicating over mountains, and I fully agree that, I mean, radio waves are not passing through the mountains, but you have a lot of example where a radio wave rebound in a mountain to reach a valley which is on the other side, and so on. And I mean, we have to make.
You went mute again. I'm not sure
that
why.
are working.
Yeah,
it's okay.
I think I can paraphrase what you're saying, which is that we know miracles do happen, and I don't want to discount those. In fact, those are pretty cool. So yeah, 619, streaming from San Diego to Santa Barbara.
Yep.
I can see that. Yeah, we used to see that all the time back in the very early days of PoC. I remember looking down there in the Southern California going, what the heck are you guys doing? Oh, right. There are mountains between those two places, and if you put a hotspot on a mountain, sure, you can do that. So again, this system is not going to I don't think it's going to be out of control and like clamping down on things, but it's a good gauge. We should fold it in somehow, find a way to fold it in. We're not going to make it rule the world, but it's an important thing that's in there. And the reason it hasn't been in there before is because it's computationally hard to do. It's hard to do on our L1 as we have it right now, our blockchain. Yep. If you put this in there, the blockchain would stall because the way that we run our consensus groups is very good for getting censorship-resistant consensus, but it's really hard to do any kind of smart contract work. We don't have a smart contract blockchain in Helium right now. That's why moving over to Solana is really cool. This cannot be done in our L1, but it can be done with a blockchain. So that's why it's on the map and hasn't been before. So let's talk about this next one here, which I think maybe the US listeners are not so aware of this, but everyone else in the world, especially Europe, has been dealing with this a long time. And hey, hot button issue, Australia, New Zealand. And that is the fact that although IoT, the LoRaWAN network, is an unlicensed radio spectrum worldwide, it doesn't mean it's like free for all. It's actually covered by several regulations, many regulations in many different countries, each of which has its own idea of what you're allowed to do. And it is quite complicated. I got into this simply learning the difference between the United States FCC's rules and the European Union's rules. It's not even translatable. You can just say, oh, the power level is different. There's different things about dwell times, how long you can stay on the air, what spreading factor you can use, how much power you can put on any single channel. It gets totally crazy. And these limits have been taken into account in the Helium code, in the region maps, as we call them. And if you put a hotspot in Europe, for example, PoC happens for you. Your beacons happen at 16 decibels milliwatt. What does that mean? You're allowed to transmit basically in the 20, that's maybe 60 milliwatts. Someone do the math. There's probably a geek out there who's doing it, typing furiously, correct me. But much less than a light bulb in a hallway for your nightlight. It is pretty low power there. And we just have to do that. That's what the rules say. You can't transmit much more than that, power-wise. Here in the US, theoretically, you're allowed to go up to 36 dBm. And so you might say, hey, 16 to 36, it's only a 20 watts. That's 20 decibels. That is, that's a factor of 100, actually, or yeah, it's 100 times more powerful, up to like half a watt, really. We're going 50 milliwatts to 500 milliwatts. And that's a big deal. And hotspots in the US can broadcast quite powerfully. What happens here is when you send a beacon out at different power levels, you get different witness results. It's understandable if you transmit at a weaker power level. If you're forced to transmit at a weaker power level, you're not going to be heard as far. But in the US, you transmit very strongly, you're heard quite widespread. This affects your rewards, ultimately. The more witnesses you have, up to a certain point, the more rewards you get as a hotspot, because we're using this as a way to measure your coverage, right? But it's unfair. It's not actually measuring your coverage very well. If two different places are allowed to transmit at two different power levels for hotspots, it doesn't actually change how well they can cover an area. There are some cases where it does, and Paul will probably speak to those. We're going to talk about join accepts and join responses. But in those parts of the world where it doesn't matter, where these particular parameters don't have any real effect on coverage, but they do have effect on PoC, we should fix this problem to make it so that wherever you are in the world, it's your coverage that matters and not your power levels. And so that we'll fix rewards so that if you're in an area that forces you to transmit quite low, your reward should go up by that amount that you're affected. So that really, in the end, if you put up a good hotspot anywhere in the world, you should expect to get a certain amount of H&T through PoC. It should be predictable that way. So that's what worldwide reward harmonization means. Harmonization being the key word, is it trying to get it flattened out so that we're really measuring and rewarding things that we want to, and not letting weird artificial limits affect to distort the results.
Dig it.
Making sense?
Yep, totally. Let's see. We're still yeah. That makes a ton of sense. I'm sure the Australians are going to be psyched to hear that, which is good. I want to go back. While you're going over that, Jeremy, we had a couple questions in the chat about this stuff. Paul, what's the link to your website where they can sign up for your console?
It's Helium IOT.eu.
Okay.
Helium-IOT.eu. So it's one of the Helium network provider. Okay, so it's a different one. And yeah, as I answered on the chat, you can run 1,000 of devices. I have the example of one of my customer, which is I think around 7,000 devices running on my console. And I mean, the load of the console is something like 5%, above 5%. So we can have much more. No problem with this. And if we look at other console like Helium consoles, we have hundreds of thousands of devices or tens of thousands of devices running this console. So yeah, that's really cool. Scalable. The advantages of LoRaWAN is really low. Not a lot of messages that are sent on every day, and they are small messages, so it's not basically really impacting the servers.
Cool. Maybe we're getting this question from Rich. We just have us out in the just LNS consoles, but it's interesting to see what people are psyched on, kind of what they're into. But Jeremy, I know you got to get shit to do. So what else we got here? We got like a many next steps.
I think it's going to be a bit more exciting because they're new toys to play with.
Yep.
Secure mappers and secure concentrators. We've talked about this for a while. What is a secure mapper? What's a secure concentrator? Well, right now the network is primarily made up a lot of really cool, very powerful, when I say powerful for the amount of energy they use, Raspberry Pis. My goodness, where would we be without the humble Raspberry Pi and what it does? It is wonderful hardware to hack on. You can boot one up. You can try all sorts of experiments. I grew up in an era of time where the Raspberry Pi used to be called the Commodore 64, which was a machine anybody could buy and play with. So many geeks grew up with that in my era, learned how to code, learned how to build the wonderful world that we're in today because of that wonderful platform. But because it's so easy to hack on, and when I say hack, I mean in the really classical way of the geeky way, the really proud way of like, I can fix this, I can build it myself. It's really easy to mess with the software, and it opens opportunities for people to play with the witness receipts, to fake them out, to put hotspots in clusters that aren't actually out there in the world.
To be fucking cheaters, I'll just say it. Yeah.
All right, yeah, there's the Nick angle. So we need we have to continue to let those exist. But if we can pepper the network, and I like to use the word peppering, because it doesn't have to be fully distributed this way. It doesn't have to be completely made of secured devices. But if we put a few of them out there in regions that are a bit more trustable, that are very hard to mess with, the reports that come from these secure concentrators, secure gateways, can be trusted a lot more. And we can start to use them to pinpoint where other hotspots are and make proof of coverage, again, more trustable. So we should, and we've already started doing this. You've seen this in HIP-72 is one answer to a secure concentrator. But the next steps here are, how do we make certain that this is an important part to the network, and how are they rewarded? And that's a big part. Not a lot of answers here, but this really talks about why it's important to do that. And let's talk about another thing, secured mappers. Concentrators or gateways or hotspots, all three really saying the same thing, sit in one place and they stay there forever. That's great. They're providing coverage and they're providing reliable standard coverage there. But there's room for things that move around. Sensors move around, and mappers are devices that use the LoRaWAN network to help check out which gateways they can talk to, which hotspots they can see. People have been doing this for fun for a long time, for free for a long time. If we build secure mapper hardware, they too can participate in proof of coverage and helping to prove not only the gateways say that they're covering this area, but an actual device out there can use a network in this area. And it becomes really important for proving coverage for devices, which is really this half of what PoC does. Right? So we're going to have to bite the bullet and adopt some secure hardware. What do you got?
One question. I mean, did you have a look on a partnership with HiveMapper, for example? Because I mean, the advantage of HiveMapper, they are building like a Google map by taking a picture when you are driving, and if you add a LoRaWAN communication on it, you can also identify what are the hotspots around, and basically you have the proof of location with the GPS plus with the picture of the street and house around and so on. So this could be a really powerful, tool to in secure things, as you get at one time a picture proving the position, the GPS plus the radio communication. You had a look at this, or?
Yeah, it's a great idea. I would be surprised if something's not being done there. I've actually been to HiveMapper's location. Nick has been there. Nick hosted a big deal with them.
Yeah.
So
yeah,
it's a cool project. I think they're planning to use LoRaWAN somehow.
Yeah, and I think to
that is
point,
an example of a secure mapper.
We're going to see. It's interesting to hear this stuff happening, and what Helium is exploring, especially with going way back in the conversation to kind of the idea of the first in or the best hotspot getting rewarded the most, or the rest of it. Is we're seeing a lot of these other kind of position projects, like HiveMapper and certainly like GeoNet, experiment with the same kind of things and try using NFTs to reward the first in and to secure some amount of rewards and to see how they reward the best or whatever it is. Like, we're going to see across this deep in space a bunch of these different projects kind of competing for the best idea, and then pretty quickly the smart people are going to be like, all right, well, that idea is better than ours, let's just use that one. And that's pretty cool to see that kind of coming down the pipe. But
well, in the end, these are all going to have to be done as HIPs. So we're going to have to pass a HIP really to say, what is a secure mapper? Who's allowed to build it? How do we make sure it's built correctly? And things like that. It's not, as you see, the paragraphs get shorter and shorter the farther out in the future we go here.
Yeah.
But that does bring me to another step that kind of dovetails into this. And that is, I would like to call this blowing up the onboarding server. May not make sense to a lot of people. It makes a huge amount of sense to me. But we should make it possible to really bring back the DIY program, what we call the DIY program, which is anybody should be able to onboard a hotspot. We need to get to a future. We don't need the specialized hardware and the secure chip in there. We can build this network. If PoC graduates and becomes mature enough to incorporate all of these things, this artificial limitation we have of having only specific manufacturers in the network, it can go away, and it should go away. That's the goal we should have here: permissionless participation in the network. We saw what it was like before. It was shut down for different reasons. We can get there. If we get all of these things in the roadmap rolled in, we'll have a very robust PoC where we can finally open it up.
And basically, it's important to notice that, for participating at the PoC, it's limited, but currently you can add as a data only any kind of hardware, and you really don't need to have a dedicated hardware. If you have a standard hardware, you need to do some command line to provide your hotspot on the network, but past this, any gateway that exists, and that means also that if you already have a network of a private network of gateways to cover a city or cover something where you deploy a service, you can migrate it to Helium network. And in my point of view, this has to be really simplified Currently, it's really easy if you know how to do this. It's just some command to pass on a wallet. But if you don't know this, it's a bit complicated. And I think we could simplify this with a UI or web application or thing like this, because it can enable a lot of corporate that already have devices that already have hotspot or gateways deployed to join the network and build with us something which is bigger. And I don't know if you have a program for this to simplify this, but it would be really interesting also.
Yeah, data only hotspots are, yeah, keep that pinned up there.
Yeah, I will.
Data only hotspots definitely a cool way to join the network, but you don't get proof of coverage rewards. And this is specifically speaking about making it possible not only to be on the network to transfer data, but also participate in proof of coverage and get those rewards. And I think, to me, that's a real big deal. So won't security be an issue with DIY? Security will be an issue with DIY if we don't get all these other things in there. But the goal here is, if we get all of these wonderful things in the roadmap rolled in there, PoC will be strong enough to withstand this. It's an algorithm that, with enough sensors, enough inputs in there, it should be able to weed out the gamers from the real coverage. And so, yeah, it sounds scary, but it's something we have to do. If we're going to get to the network of our dreams, and we can do it, we just have to roll in these features.
Yep.
What's an estimate of secure concentrators cost? Boy, that's a great question to have Paul. I don't know if the other Paul would call it DynaCore, 𝗪𝗲. I'm mispronouncing his last name. Apologies, Paul. To come in here and talk about it. The secure concentrator, it's basically, if anybody's ever built one of these concentrators yourself, it's you're taking a standard core cell design, which is 2 radios and 1 little controller, the SX12. I'm not going to spit out the numbers because I get it wrong. You're just adding in another chip here, which is a little bit higher powered CPU. I think, honestly, though, we're looking at a couple $100 maybe. So yeah, they're going to cost more. Let's be real about it. I don't know exactly how much. Hopefully the market can help solve that too. There's no reason it has to be made by any one manufacturer or being monopolized that way.
Yep. I'm just cycling through some of the comments. I was trying to get Dave to come on to answer stuff like this. Paul, have you paid attention to this, or Jeremy? Gaming has slowed down since the price of HNT has dropped.
I think I don't know. People, probably. If there's less incentive to do it, if people, the gamers probably were selling their tokens immediately as soon as they got them. So that's how they saw it as a business.
All right.
Many people do. So I imagine it's dropped, but it hasn't stopped. Certainly people are still doing it. Maybe for the fun of it. Who knows?
Yeah.
Paul, you have the data? Have you looked at any of those?
Yeah,
kind of hard to
it's really difficult to estimate the gaming level. I'm really not really looking at this basically. What for sure, in my point of view, currently investing in new hardware, deploying for doing gaming, the return on invest will be really long currently. But people can trust on the increase of the token value and maybe get some HNT for future. But in my point of view, it's at a certain period of time, it was really interesting, and there was not a lot of protection against this. The denial list was not there, and so on. So a lot of gamer arrived. And now, if you start gaming, you have a big chance to be discovered, to be deactivated, and you know that selling your hardware will be really complicated. Even if you put it on eBay, if you are on a deny list, I'm not sure that someone will want to buy your hotspot. So it's basically hardware loss. So my point of view, it's not a good business, but I don't know. People are crazy.
Well, it does bring up, it's a segue to something I do want to talk about, and that's the deny list. So the deny list actually complicates the ability right now to measure if gaming has gone up or down, for the very reason that a lot of the gamers are snared up in it, and so they're off the network. So we don't have any of those metrics now. I think it's done a fantastic job for some of those. Good job, community there. The deny list needs to die. It needs its function needs to live on as PoC does it itself. And I think it needs to happen at a much more granular level. PoC is going to graduate to a level where it can deny rewards for specific beacons and witnesses, and maybe let others flow through. This concept of wholesale shutting off a hotspot forever, I think, is a bad idea. I mean, it makes the hardware a brick. We should encourage people to come back and deploy better. We need more hardware, and we need to have PoC do it so there's not human beings running it. Right now, there's a lot of stuff that's algorithmic in there, but it needs to happen faster, have a faster loop, and we need to, let it be more flexible in terms of how long it lasts and what it does. And so that, I don't know if that belongs in the PoC roadmap, but do know that's one of my goals is to get rid of the deny list, make it automated, and not be like a list that is curated by hand.
Yep. Jerm, thanks for coming on, dude. We're at 10 o'clock. Was there anything else big that you wanted to hit? I think we came to the end of the document, right?
Yeah, we did. Amazing.
Okay, cool. I saw, just so that the folks watching this feel, seen, right, and heard, is I'm seeing all the questions about Wi-Fi. I'm seeing the questions about how much it costs to run an Oracle. I'm like seeing all the questions in the chat. I don't think we have time to hit them all. Best place to get those answered is typically on the Helium Discord. Is cruise around, find the right channel to ask that question and ask it. If you can't find it, then you can always reach out to me and I'd probably be able to point you in the right direction. But yeah, I see all the questions on there. We got an hour on Fridays. We're now 1 minute over, which I'm fine with because it took me like 4 minutes to get my tech stuff sorted in the beginning.
It was my fault too. I joined late.
Good. No, I think we're good. Paul, anything else to hit before we sign off here?
No, nothing special. I have a lot of questions also around Oracle cost and how to support all the computation we just discussed on Oracle without making it a really huge machine, expensive, and so on. But let's keep this question for next week, maybe.
Okay.
And I think it's an interesting point. How
cool.
it's going to be run, and also who is going to be the Oracle. Currently, Oracle are all managed by Helium, and so how it's going to be evolved. Yeah, some question I have around this also. Yeah.
Okay, cool. So maybe we'll shoot that for next week. Okay,
as a reminder, I am Jerm on Discord. Yeah, contact me there. I'm always on there. Always chatting with people. Love this subject. And apply. Please apply if you really love PoC and love digging around with it. Apply to the working group. It's there on Discord in the announcement. And super important to have as many good, awesome people in there.
Yeah, totes. Ripping. Well, I think that'll do it. Jerm, thanks again for coming on. I always like hanging out with you and Paul. It's like it's not drinking from the fire hose. It's like drinking from the reservoir where the dam burst. It's like there's no chance of keeping up, but we all do the best we can. And it's good to hear that kind of smart people are figuring this stuff out, and that there's a lot of opportunity for people to contribute as well who maybe don't have the same technical skills but can see can see different perspectives and add them in. So. Cool. I think that'll do it for the week. We'll see you next week. Paul, I like the idea of doing an LNS and Oracle question thing, so maybe we'll put that together this week and come up with some questions and hit that next week. But thanks for coming on, guys, and I will see you guys next time.
See ya.
Thank you.